Now, let us take a look at what collinearity and parallel vectors basically look like and how are we going to calculate them. So let's say first, let me talk about parallel vectors. Let's say if I have two vectors given to me, let's say this is my A vector and this is my B vector. Now, if these two vectors are parallel, then they are surely going to follow this pattern, which is A vector is equals to lambda times of B vector. Now here lambda is a scalar quantity. Keep this thing in mind. Now for A and B to be parallel to each other, of course, A vector needs to be equal to lambda times of B vector. Now there shouldn't be any constant added or subtracted in this entire equation. The only thing is that a constant is multiplied, which basically means that these two vectors are going to be somehow proportional to each other. They're only going to be a difference of lambda between these two. So keep this in mind about parallel vectors. And now when I talk about collinear vectors, let's say I have been given three vectors, which are A vector, B vector, and C vector, and they have been multiplied with some constant and it equates to zero. Then what are the conditions for which I can say that all these three vectors would be collinear? So let's say if I have been given this vector, xa vector plus yb vector plus zc vector is equals to zero, then A vector, B vector, C vector would be collinear if I have x plus y plus z as 0. Now remember this thing, all these three are not separately 0. However, there's some equates to 0. So keep this thing in mind. This can happen only when x plus y plus z is equals to 0. Here x and y and z, all three are not together 0, because if all these three together become 0, then there is no use of our entire huge collinear vector, right? So all these three, their sum must be 0, but they together, all of these three cannot be 0. So keep this thing in mind for collinear vectors. So now let's talk about their geometrical interpretation, or what would their projection be on some other vector. Now let's say, I hope you all must have studied in your physics. Let's say if I have a triangle which is in this format, I have a theta angle here and this hypotenuse is my L angle. So what do I use to write down my base? It used to be L cos theta, right? And this used to be L sin theta. So that is exactly what we are going to do here. Let's say if I have this vector as A vector and I have a B vector below. And now I need to find out the projection of A vector on B vector. So what would I do? I will simply draw a perpendicular line to B vector, and based on this perpendicular line, the point at which it intersects the B vector, its distance from O or the origin would become my projection. And what would this projection basically be? A vector cos theta. So this is basically A vector modulus cos theta. So to find out the distance. Now, this was our way of finding out the projection of A vector on B vector, and we are finding out the magnitude here. Now, what if we need to find out the um, vector itself? So we know that we found out the magnitude of our projection. It is going to be A vector modulus cos theta. Now, how would I represent the direction? I can simply write down B multiplied it by B cap. It would give me the direction, right? So let me write it down for you. Let's say if I need to find out projection, I'm just finding out the magnitude, let me assume, of A vector on B vector. Then what is the formula to find out my projection of A vector on B vector? It is going to be A vector dot B cap. So this can be written as A vector modulus B cap modulus cos theta. And what is my B cap basically? My B cap is B vector upon B vector modulus. So this would become A vector. This would be B vector upon B vector cos theta. So this and this would get cancelled out and I would be left with modulus A vector cos theta. So this is the formula. That is the most important one which you must remember. A vector dot B cap. Now let's say if I reverse this entire thing. Let's say if I need to find out the projection of B vector on A vector, then this would have become, my answer would simply become B vector dot A cap. And I can open this up using my dot product. I can open up my a cap as a vector by a vector modulus, and then I would get the same answer as b vector cos theta, or the angle with which they are separated. So this was the way of finding out the magnitude of the projection, which is basically this distance that we are talking about. Now let's say if I need to find out the projection vector. So projection vector of a vector on b vector. So of course the magnitude is going to remain same. The only thing is that since it is a vector, so I need to assign it with a direction as well. And what is the direction of my magnitude? It is basically in the b vector only. So I would assign the direction as b cap. Multiplying this by b cap, I would get my direction. So this is my projection vector of A on B. I hope you are understanding this. B cap, since it is a unit vector, it wouldn't have any magnitude. That means B cap here is only representing the direction. So basically this is my magnitude, and B cap represents the direction. So keep this thing in mind. So this is how generally projections are found out on different vectors. So here again, the same things have been repeated. Let's say we need to find out projection of A vector on B vector. So it is going to be A vector dot B vector upon B vector modulus whole square into B vector. So if you look at this carefully, isn't this A vector dot B cap into B cap? Basically, if I remove these two B caps, it is going to be B vector upon B vector modulus. So that is why it comes out to be square below, and we have this. Now in the scalar form, of course, we do not need to attach this B cap. So it would simply be A vector dot B cap. So keep this formula in mind. It would be quite helpful for you. There are a lot of questions that are asked from this formula. So you can solve it using these. Let's look at one ourselves. Let's look at this one. So A vector has been given to us, B vector has been given to us, where alpha is greater than 0. So in both these vectors, there is an unknown point, which is my alpha. If the projection of A vector cross B vector on the vector, this is 30. So let me assume that this vector that has been given to us is my C vector. So first of all, let me find out my A vector cross B vector. It is of course going to be another vector, right? So if I find out my A vector cross B vector, what is it going to be? Determinant I, J, K. What is my A vector here? Alpha 1 minus 1, 2, 1 minus alpha. We had studied this in cross product, so this shouldn't be a new thing for you. Now if I try to find this out, it is going to be I cap minus alpha plus 1 plus j cap. This would be minus j cap, and what are its coefficients going to be? Minus alpha square plus 2 plus k cap, and here I'm going to have alpha minus 2. So if I try to write this down in a more simpler way, this is basically I cap 1 minus alpha plus j cap alpha square minus 2 plus k cap alpha minus 2. So this is my A vector cross B vector. Now what have they told us? That A vector cross B vector, when its projection is taken on my C vector, the magnitude is coming out to be 30. That means A vector cross B vector, when I take its projection on C vector, so it is going to be C cap here, this value comes out to be 30. This is what the question is trying to tell us. Now based on this, since we would have our A vector cross B vector in terms of alpha, we would have C cap. We can find out what our alpha is going to be. So let us try to solve it. So first let us find out what our C cap vector is basically. It is going to be minus 1 by, if you look at modulus C vector, it is going to be root under 1 plus 4 plus 4, which makes it 3. So here I would have a 3 I cap plus 2 by 3 j cap minus 2 by 3 k cap. So this is my C cap that I found out. And I know my A vector cross B vector, I know its value as well. It is I cap 1 minus alpha plus j cap alpha square minus 2 plus k cap alpha minus 2. So I found out my A vector cross B vector and my C cap. Now I simply need to take their dot product into B vector dot C cap. So what would their dot product simply become? I'll simply multiply all the respective I caps, J caps and K caps, and then we'll see what are we getting. So this would become alpha minus 1 upon 3 plus, here we would have 2 alpha square minus 4 upon 3, and here we are going to have plus, sorry, plus 4 minus 2 alpha upon 3. So from here, let me just simplify this. So this, I can take 3 as LCM, of course, it can be taken as LCM. So I would have 2 alpha square minus alpha minus 4 plus 4 gets cancelled out, and we would have minus 1 upon 3. Now, as per the question, we know that this value is equals to 30. So simply let's just solve this. So this would become 2 alpha square minus alpha. This would become 90, and here we would have minus 91 is equals to 0. Now, if I try to find out the roots of this equation, basically, what would I have? I would have one of the roots as alpha minus 7, and the other root would become 2 alpha plus 13 equals to 0. So this is what I'm going to have. So basically, what do I get my values of alpha to be? My alpha is either 7 or my alpha is either minus 13 by 2. Let's say if you are not being able to factorize this quadratic equation, you can simply use your solution of quadratic equation, which used to be minus b plus minus root under b square minus 4ac upon 2a. Based on that also, you can solve this quadratic equation. Now, since that we've found out our values of alpha, we've gotten two values. Now in the question, they've also told us that alpha is always greater than 0. So we cannot ignore this portion. That means this negative answer would get rejected, and we would have 7 as our answer. So again, a very simple question. The only thing is that we needed to use the concept of projection that we just studied. So remember the formula of projections. Do not confuse yourself with different types of dot products or cross products. Rest, everything is easy for such type of questions. Now let's talk about parallelogram. I hope you all know what a parallelogram is. Let's say this is my parallelogram. Of course, my sides are going to be parallel, right? Let's say if this is my A vector and this is my B vector, then this area of parallelogram is going to be of this formula, modulus A vector cross B vector, where A and B are adjacent sides of the parallelogram. Now I hope you all know, since this is a parallelogram, so this is going to be lambda times of A vector. This is going to be lambda times of B vector. This is going to be lambda times of B vector. So this is my parallelogram. And now let's say if I connect the diagonals amongst each other and I represent them as well with some vectors d1 and d2. So I can also write down my formula as half of d1 vector cross d2 vector. So where d1 and d2 are diagonals of the parallelogram. So keep this in mind. And if I need to find out my area of triangle, so basically my area of triangle is half of area of parallelogram. So keep this formula in mind. There are three formulas basically that you studied here. First is area of parallelogram. Once where two adjacent sides are given, it is simply A vector cross B vector magnitude. If let's say the diagonals of the parallelogram are given in terms of vectors, your formula becomes half of d1 vector cross d2 vector. And if you need to find out your area of triangle, it is always half of area of parallelogram. So if let's say if the diagonals of some parallelogram has been given, and you need to find out the area of half portion of that parallelogram, which basically becomes a triangle. So it would become 1 by 4 d1 vector cross d2 vector. So keep these formulas in mind. So now let us look at this question now. What has been given to us? Let A vector is equals to this, B vector is equals to this. If the area of parallelogram whose adjacent sides are represented by vectors A and B is this, then the value of 2A vector. So basically, we need to find out our what exactly our A vector and B vector are, because there is a unknown variable in them, which is my alpha. So I need to find out my alpha. Now they've told us that A vector and B vector are the adjacent sides of a parallelogram. So my area of parallelogram basically becomes A vector cross B vector. So simply let's just find this value out. It is going to be I cap j cap, k cap, and below we would have alpha 2 minus 1 minus 2 alpha and 1. So if I try to solve this, I would have I cap 2 plus alpha minus j cap alpha minus 2 plus k cap, and here I would have alpha square plus 4. So this is my A vector cross B vector. Now I need to take its magnitude as well. So A vector cross B vector, the magnitude would basically become equal to, sorry, this was just A vector cross B vector. Now finding out its magnitude, this is basically my area of parallelogram. So this would become root under alpha plus 2 whole square plus alpha minus 2 whole square. Since it is squared, so of course taking the minus 1 doesn't matter here, it is going to get cancelled out. So I'm just not writing it, plus 4 whole square. So this is my area of parallelogram. Now as per the question, they've told us that this area of parallelogram is nothing but 15 alpha square plus 4. So let me just solve this equation and find out my answer. What if I square both these sides? So if I square both these sides, I'm going to get, and I'm opening up these brackets as well. So this would become alpha square plus 4 plus 4 alpha plus alpha square plus 4 minus 4 alpha. And here I would have plus alpha to the power 4 plus 16 plus 8 alpha square. This value is equals to 15 alpha square plus 60. So this is what has been given to us in the question. Now simply by solving this, we can find out our values of alpha. And based on our values of alpha, we can find out whatever has been asked to us in the question. So from here, 4 alpha minus 4 alpha gets cancelled out amongst each other. We are going to have basically alpha to the power 4. And here we would have plus, this would become 8, 9, 10. 10 alpha this side, so this would become minus 5 alpha square. And now we would have 4 plus 4, 8. 16 makes it 24. And 24 when taken minus with 60, we are going to get minus of, this would become 36. This is equals to 0. So now if I take my, assume my alpha square to be, let's say, some variable t. So simply I can find out my values. This would become alpha square. One of the variables is going to be minus 9 and another one would be alpha square plus 4. This is equals to 0. So these are my factors of this quadratic equation. Of course, let's say if it becomes difficult for you to solve such type of quadratic equation, assume your alpha square to be t. You would have t square minus 5t minus 36. Use your solution of quadratic equation, find out your value of t, replace your t with alpha square, and that is what you are going to get. So from here, of course, this value cannot be equal to 0. That means only this is the value that can be equal to 0. So I've gotten my alpha square to be equal to 9. Now let me try and solve whatever has been asked to us in the question. Let me separate this out. So what has been asked to us in the question? We need to find out 2 of modulus a squared plus a vector dot b vector squared plus b vector whole squared. Now I'm not finding out my alpha as minus 3 or plus 3 because I can see that the question that they've asked us, all the values are squared. That means I'm going to have alpha square only in them. So let me find out my a vector modulus. What is it going to be? Root under alpha square plus 4 plus 1. What would be my modulus b? This would be root under 4 plus alpha square plus 1. And if I find out my a vector dot b vector, what is it going to become? Alpha into minus 2. So minus 2 alpha plus 2 alpha. And in the end, I'm going to have a minus 1. So this and this would get cancelled out. I just have a minus 1 here. Now if I start replacing the values, I would have 2 times of alpha square plus 5 plus 1 plus I would have alpha square plus 5 here as well. So this would become 3 times of alpha square plus 5 plus 1. From here we know that my alpha square is 9. So I'll just simply replace the value of alpha square as 9. This would become 9 plus 5, which makes it 14. 14 threes are 42 and plus 1 we would get 43. So 43, this is my answer. So this is how you are supposed to solve questions. Again, very easy, just formula based questions. And this was also a question that was asked in one of the previous year JEE mains. So you can see the level of questions that are asked. Completely formula based, no new concepts that are used. The only thing is that you need to solve such questions with complete thoroughness and patience so that you do not make any silly mistakes of sign or anything like that. Now, talking about angle bisector, of course, here you can see, let's say if I have A vector, I have B vector, there can be a C vector which bisects A and B. So basically this angle was theta. It has been bisected into two parts, theta by 2 and theta by 2. Now sometimes what can happen is, let's say if this is my A vector and this is my B vector. So I can have an internal angle bisector C vector. Sometimes I can also have an external angle bisector as well. So this is basically my external angle bisector. And when does this come here? So basically in my external angle bisector, what do I consider is that my A vector stays positive. However, I take the negative of B vector. So basically this is the vector that I'm talking about. This is minus B vector. So this is the direction in which my minus B would be. And if I take A vector and B vector, this C vector would become its external angle bisector. External angle bisector. And this C here is my internal angle bisector. So of course, how can we find out these external angle and internal angle bisectors? Simply, there is a formula for you to remember. Let's say if I'm finding out the internal angle bisector, then I would write down my C vector to be lambda times of A cap plus B cap. And if I'm finding out my external angle bisector, if I'm finding out my external angle bisector, it is going to be C vector is equals to lambda times of A cap minus B cap simply. Again, nothing much to discuss or understand here. Simply there are two formulas for angle bisector which you need to remember. Now we'll look at a question and you can see how we can use such formulas as well. Now again, the lambda that has been used in this formula is a scalar quantity. It is going to be varying depending on the vector or the conditions the vectors are in. So of course the same things have been mentioned here. Vector along internal angle bisector and vector along external angle bisector. Now let's look at this question. A vector A, where we have two unknown variables alpha and beta, lies in the plane of vectors B vector and C vector. If A vector bisects the angle of B vector and C vector, then. So basically we need to find out what our A vector is going to be or how can we represent it in terms of lambda and any other variable. Now in the question, they haven't told us whether it is bisecting it internally or is it bisecting it externally. So we have to take both the cases in our account. So what is our first case? Let us talk for internal angle bisector. So if I talk about internal angle bisector, then I can say that my A vector, since it is the one which is going to divide it, it would be equal to lambda times of B cap plus C cap. Now simply let me just replace the values. Here I would have lambda times of what is my B cap. So let me first write down their separate values. So basically my B cap would be equal to 1 by root 2 I cap plus 1 by root 2 J cap. And when I talk about my C cap, it is going to be root under 1 plus 1, 2 plus 16, 18. So root under 16, root under 18, which is 3 root 2. So this would become 1 by 3 root 2 I cap minus 1 by 3 root 2 J cap plus 4 by 3 root 2 k cap. So these are my C vector and B vector. So now let me find out my B cap plus C cap. What is it going to be? If I add these two, I would get 4 by 3 root 2 I cap. And here I would have 3 minus 1 would give me 2. So this would be plus 2 by 3 root 2 J cap. And I would have a plus 4 by 3 root 2 K cap. Now I found out my B cap plus C cap. Now basically if I multiply this vector with lambda, I'm going to get my A vector. So here, sorry, if I'm representing this with a modulus, that means my A vector is also in modulus. If I simply represent this without a modulus, then I need to represent this as vector format only. So this would be in vector format only. So from here, if I start equating my A vector, which is given to me as alpha I cap plus 2j cap plus beta k cap and my B cap plus C cap times of lambda. What does this comes out to be? 4 lambda upon 3 root 2 I cap plus 2 lambda upon 3 root 2 j cap plus 4 lambda upon 3 root 2 k cap. So this is what I'm getting. Now we know that A vector is going to be equal to this vector only. And here we can see that alpha is an unknown variable. So if I equate alpha to 4 lambda upon 3 root 2, we are not going to get any value, right? However, if I look at the j cap value, I have a constant here and I have lambda here. So from here I can find out my lambda. So if I equate these two equations, I would have 2 is equals to 2 lambda upon 3 root 2. So from here, what is the value of lambda that I'm getting? It is coming out to be 3 root 2. So first thing we found out. Now after finding out lambda, of course, you can find out your alpha and beta as per given in the question. However, in the question, we just had to find out what our internal angle constants is going to be. So this was for internal angle. Now let us solve for external angle as well. What if we have to find out our external angle? So our A vector would basically be equals to mu times of B cap minus C cap. So basically my value of B cap minus C cap, let me write it down directly. B cap minus C cap. So 1 by root 2 minus 1 by 3 root 2. This would become 2 by 3 root 2 I cap. Here I would have a plus 4 by 3 root 2 J cap. And here I would have minus 4 by 3 root 2 K cap. So this is my B cap minus C cap. Now if I multiply this by mu, upon multiplying this by mu, I need to equate it to A. And what is the value of A that I'm going to equate it to? 2, which is my J cap because I have a constant there, right? So I would equate it to J cap. So I would have basically 2 is equals to 4 mu upon 3 root 2. So from here, what is the value of mu that I'm getting? My mu is coming out to be 3 root 2 by 2. So I found out my mu, I found out my lambda. Now based on this, I can of course find out my A vector as well. When it is going to be an internal angle bisector, its vector is going to be different. And when it is going to be an external angle bisector, its vector is going to be different because the mu has been changed. Earlier it was 3 root 2, now it has become 3 root 2 by 2. So keep this thing in mind. This is how you are supposed to use this formula in questions given to you. Now, talking about triple product. Now, this is a topic which is not there in your syllabus for JEE Mains, but still I'm just going to give you the formula of how you can find out triple product. Of course, there are two types of triple products. One is a scalar product and one is a vector product. So I'll just give you the formulas. Again, if you do not want to remember, it is fine because this is not included in your syllabus. However, up till last year, this portion used to be included in the syllabus. So I'll just give you a brief overview of the formulas. Let's say if we are finding out our scalar triple product. Scalar triple product. So my scalar triple product is nothing but, of course, by the name itself, you can understand that I am supposed to get a scalar value. So this is A vector dot B vector cross C vector. So this is how scalar triple product is found out. And there is another way of representing this. It can be represented in this format as well. So let's say if values are changed, let's say I have B vector, A vector, C vector inside square brackets, then it would become B vector dot A vector cross C vector. So keep this in mind. What does this value, of course, equate itself to? This would become A vector into B vector modulus into C vector modulus into sine theta into cos phi. So basically the angles that we are trying to find out. And then if I need to find out their proper modulus values, I can write down A1, A2, A3. Now A1, A2, A3 are the coefficients of I cap, J cap and K cap for A vector. For B vector, I'm assuming it to be B1, B2, B3. So it would become B1, B2, B3. Here I would have C1, C2, C3. So this is how scalar triple products are found out. talking about vector triple product. Of course, by the name itself, it suggests we are only going to have vectors here. So let's say if this is the vector triple product. So how can I write down the solution of this vector triple product? It would become a vector dot c vector into b vector minus a vector dot b vector into c vector. So keep this formula in mind. Do not, of course, mismatch or confuse yourself with the minus sign here and there. This is how vector triple product and scalar triple products are found out. Again, the same things have been mentioned here. There are a few properties as well. Cyclic property which it follows. Here you can see that if I'm finding out my scalar triple product, it can be written in the determinant format as well. And when I talk about vector, it follows the distributive property. So keep these things in mind. Again, you can just have a look at this. It is not necessary for you to remember and understand this very properly. Just have a look at it so that if by chance this type of question comes in your examination, you shouldn't be unaware of what you must do next. So that was all about the theory portion of this chapter. As I mentioned, this chapter comes under 3D geometry only, and from 3D geometry, you're going to have at least one question in each and every paper. And the questions that are generally asked for from vectors are mostly formula based only. As you could have seen, whatever formula we studied, the practice problem that we did for that, it was all previous year JEE main question. So you can see the level of questions they are asking. So of course, it is recommended for you to remember the formulas properly, know how you can find out your cross product and dot products efficiently.